Hi, Assalamualaikum. My name is Mohamad Nazhan Syahmi bin Kamal. I am from 4 BMFG 3/2. Today I will present my PSM subject. The topic that I take is synthesis and characterization of hydroxyapatite from natural resource from biomaterial. My supervisor is Puan Adibah Haneem Binti Mohamad. So this is my presentation outline, which consists of background, application of HA, problem statement, objective, methodology, result and discussion, conclusion, and references. First, I will talk about the background of the study. A biomaterial is a material that has been used and adapted for medical purpose and more. What is a biomaterial? A biomaterial is basically a biological or synthetic substance which can be introduced into body tissue or else without give a negative impact on the body. Biomaterial that is being focused on and specific is organic hydroxyapatite from natural resources. In this case, I choose black tilapia fish scale. All of the tests with different parameters has used black tilapia fish scale as the natural resource. Why HA as a biomaterial? HA it have good bioactivity, biocompatibility, and osteoconduction properties. So what is the importance of hydroxyapatite? It can be as a filler, improve mechanical qualities like tensile strength, fracture strength, impact energy, and hardness, and else improve the biocompatibility of composite. Can act as bone tissue degeneration, particularly in certain joints such as the knee and hip, necessitates the use of orthopedic implants. Last but not least, the mechanical characteristic and biocompatibility of epoxy resin increase when adding hydroxyapatite powder from fish scale. We can use it as a added nanomaterials to the epoxy resin also. After that, I will talk about the problem statement. Problem statement is basically from the reading from few journals, and the first problem that I found is sustainability and recycling of fish waste, particularly in Malaysia. As an example, in Malaysia, we eat a lot of fish, whether it morning, noon, or night. Therefore, there are a lot of fish part waste. Other than reducing the waste, the researchers suggest to turn the waste into beneficial products. As example, as a coating for a biomedical application. And the next problem statement is HA from fish scale is still in research and doesn't have really accurate parameter for its synthesis process. For example, in my experiment, we use thermal treatment. The parameters is calcination temperature. If we do excessive or insufficient calcination temperature, it will lead to the producing of beta TCP. Beta TCP uh, can't can use as a final product because it has bad effect to the biological body, for example, human being. Next is objective. The objective is to synthesize HA from black tilapia fish scale using heat treatment method, as I said before, and then to characterize the physical and chemical properties of the synthesis HA using SRD, FAR, and PSA, to analyze the effect of calcination temperature of 300, 700, 1800, 900, and 1000 Celsius on the properties of the synthesis HA. All of these will be explained further at the result and discussion. The next part that I will explain is methodology of extraction of fish scale based hydroxyapatite. Which means from the fish scale we turn into the HA. How? So first boiling the fish scale for 30 minutes and then dry for 1 or 2 days at room temperature. For me, I tried it for 2 days in room temperature. After that, I use ball milling to grind it into micrometer size. After that, we divided into two categories, non-calcination and then calcination. For the calcination, is divided into another 5 temperature, which is 600, 700, 800, 900, and 1000 with a heating rate of 10 Celsius per minute. Then let it cool in the furnace until 40 degrees Celsius in the rate of 10 Celsius per minute. Then the calcination and non-calcination sample we will characterize with the PSA, FTIR, and SRD. After that, we further to the result and discussion of the first characterization method, which is SRD. Uh, from the SRD, we can see the most apparent and sharpest peak related to the high crystallinity of standard hydroxyapatite. From the standard HA, we can see at the peak of 32 until 34 degree, we can see the existing of peak, and the peak is sharpest and highest at the 1000 calcination temperature. And all the peaks from the SID result doesn't indicate any peak of calcium carbonate and calcium oxide. There may be a peak, but it's not an obvious peak, which means the more dense substance is HA substance. Greater calcination temperature give greater intensity, as we can see in the graph. Best crystallinity of HA can be got from the temperature of 900 and 1000. As you can see, because the peak is more obvious and more higher compared to the other calcination temperature. From the SID result also, we can get the score. For this score, I have focused on 3 subcomponents, which is HA, beta TCP, and calcium carbonate. As we can see, at the 1000 degrees Celsius, we finally success to get rid the beta TCP. Although the HA score at the 1000 degrees Celsius is slightly lower than the other calcination temperature, but following the crystallinity and the highest peak is at the 1000 degrees Celsius of calcination temperature. That means it's still the dense HA can be obtained. From the SID result, we can do the crystallite size assignment, which means we can know the crystallite size. Crystallite size is important for a micro or nano materials. We can measure the crystallite, we can calculate the crystallite size using Schrödinger equation, and the data is taken from SRD, and few data such as lambda and beta we taken from the journal. From the calculation result, we can observe that the highest crystallinity is at the 1000 calcination temperature, and it is slightly high compared to the 900. Let me explain what is crystallite size. Crystallite size, let's say we zoom into the particle of HA, we can see the crystal lattice arrangement. In the 1000 calcination temperature is more dense compared to the other temperature. Then we go to the second characterization, which is in terms of chemical characterization, which is FTIR. FTIR used to trace the chemical bonding of a substance. From reading, we know that phosphate group, carbonate group, and hydroxy group are important to indicate the existing of HA. We can see at the bending modes of 630 until 562, there is a bending mode there that going downwards, which indicate the existing of phosphate group. And then at the wave number of 1000 until 1018, which is typically a place for carbon apatite, we can see the calcination sample have greater carbonate group apatite compared to the non-calcination. And then we go to the next phase, which is 3700 and 2900. That is a place for OH and H2O, but before it turns into OH, we can see H2O broad peak at the uncalcinated sample. But for the calcinate sample, there is no broad peak that indicate H2O. All of the H2O has turned into the OH line indicator. This we can conclude that the phase transition to become HA has been fully utilized by the calcination process. After that, we go to the third characterization method, which is in terms of physical. From the particle size analyzer result, we can know that all the 6 samples are in the micrometer range. Unbroken aggregate of the sample produced at low concentration temperature occur. There was 3 size aggregate, which is 10 micrometer, 150 micrometer, and around 220 micrometer. Dispersion into their primary microparticle size at concentration temperature of 900 and 1000 is easier, indicating the van der Waals force keeping them together has been brought down due to sufficient heat. 900 until 1000 concentration temperature, which resulted in a more consistent shape and size of nanoparticle. Consistent shape and size makes HA easy to manufacture and make it easy to become coating because of the same effect. You can see the color changes from left to right. Non-concentration is basically white in color, which is the natural color of its scale. At the 600 and 700, it turns black due to the burning process that occur to the unwanted substance. The unwanted substance may not be fully get off and burn into black. Starting at 100 and 900, the black color starting to pale, and at 1000 degrees Celsius concentration temperature, it turns into white. So my experiment uh, is a success because it's same as the journal say, which is actually HA color should be white. The conclusion: HA was successfully produced from black tilapia fish scale with using the heat treatment method. The formation of HA can be confirmed from the SRD and FAI analysis. As the concentration temperature increase, the color of HA powder gradually change from black to white. With increasing concentration temperature, the crystallinity of the synthesis HA is significantly enhanced by the crystallite size assignment we did before. Okay, that's all for my presentation. Thank you.